In this video, we will demonstrate Gopher. It is a system that generates interpretable database explanations for fairness. First of all, let's look at an example. Assume we have a dataset and a machine learning model. Then we feed the dataset and then test the machine learning model on the test set and predict to get a bunch of predicted labels. And based on these predicted labels, we can compute the corresponding fairness metrics, such as the equal opportunity, which is basically the difference between the true positive rates of the privileged group and the protected group. So if this difference is large, that means that the true positive rate of the privileged group is much larger than the true positive rate of the protected group. Then there is a large bias. The goal of explainable AI is trying to identify a set of features or training data points that are responsible for this bias. So the existing explainable AI methods can mainly categorized into two classes. The first class is feature-based explanations. So as we can see in this plot, feature-based explanations tries to quantify how much an input feature value contributes to an ML model's predictions. Those feature-based explanations are designed to review the dependency patterns between the input features and the output of the machine learning algorithms. And there are multiple popular feature-based explanation generation methods like LIME and SHAP. However, these feature-based explanations fail to generate diagnostic explanations that can let users trace the unexpected or discriminatory algorithmic behavior back to its training data. Hence, they cannot be used to debug the bias. In contrast, another kind of explanation is based on data points, which means they try to trace the source of bias back to the training data. And so as shown here, the instance-based explanations tries to identify the source of bias as a set of data instances that have high influence. However, these data points are not summarizable. So as shown in this table, we cannot interpret the results and get some interesting insights from it. So instead of generating such kind of instance-based explanations which are not summarizable, we can generate patterns like the one we show here, described by a set of predicates. And based on this motivation, our system Gopher is designed to identify cohesive subsets of the training data that are most responsible for the bias and can compactly describe the subsets using patterns that are conjunctions of predicates. In general, Gopher supports two kinds of explanations. The first kind of explanation is a removal-based explanation. So as we can see, Gopher can list a set of patterns that are most responsible for the bias. The removal-based explanation basically means that by removing the data instances included or belongs to the pattern from the training set and retrain the model, the bias can be reduced. And instead of removing these subsets of data from the training sets, we can also update this data, and therefore we have the second kind of explanation, the update-based explanations. The update-based explanations is basically trying to reduce the model's bias by updating these data points instead of removing them. And the experimental results shows that by updating the data points, we can also largely reduce the model's bias. Now I will guide you through the demo of our Gopher system. So first of all, we can specify the dataset and the classifier in the input section. And we can see after the dataset is changed, the dataset preview is changed correspondingly. Also, the sensitive attribute and privileged and protected groups are changed based on the datasets. Then we can train the selected classifier on the selected datasets. After we click this button, we can see the basic information of the trained classifier and the fairness matrix of this trained classifier. Then we can click the Start Pre-computation button to do the pre-computation, which can help us generate the patterns more efficiently in the following steps. Then we can move to the removal-based explanation. Here in the settings section, we can set the levels of the lattice-based search of the Gopher system, and also the lower bound and upper bound of the supports of the top patterns that generated by Gopher. And also we can specify the threshold for the containment here. Higher threshold of this containment filtering means that we would allow more overlapping between the top explanations generated by Gopher. We can also specify the fairness matrix we want to repair in this section, and we can go back to the Home tab to see which fairness matrix we want to repair. And after these settings are specified, we can then click this button to generate removal-based explanations. And in the section below, we can see the comparison between different patterns generated by Gopher and FO trees. So in this plot, the original bar means the fairness metric of the original biased classifier trained on the original training datasets. And these three bars represents the fairness matrix after we remove the data points included in corresponding patterns. And we can see, especially for the Gopher pattern 1, which refers to age large or equal to 45 and gender equals female. After we remove the data instances in this pattern, the bias has been largely reduced. And also we can see the comparison of the FO tree, which is the baseline. And to get more insights about why removing these patterns can help reduce the bias, we can also look at the class distribution comparison here in this section. And we can analyze, for example, for the first pattern, which is Gopher pattern 1, in the group of data points that have age large or equal to 45 and gender equals female, there are a lot of positive labels. And this would somehow increase the correlation between the positive label and the old group of people. And besides, we can look at this Gopher pattern 3, which has relatively more negative labels. And here, this corresponding pattern is age less than 45. And this increases the correlation between the negative label and the young group people, and therefore can also increase the bias. And so by removing the data instances in these subgroups, we can of course reduce the bias by reducing such correlation. After we generated removal-based explanations, we can go to the third section, which is for the update-based explanations. So here, we can either load the influential patterns which are generated by Gopher in the previous removal-based explanation section. We can either load them, or we can also choose some user-defined patterns to update, because the best pattern to remove does not necessarily means the best pattern to update. But in general, trying influential removal-based patterns can be a good choice. So here we can try to update the first pattern. And by clicking this update-based explanation, we can see the corresponding results in the sections on the right and below. So firstly, there are two plots we can look at it on the right. The first one is a fairness comparison plot. The original bar refers to the original fairness matrix of the biased classifier, and the updated bar refers to the fairness metric of the new classifier that are trained on the new datasets. Here in the new dataset, the data instances in the selected patterns are updated with the same direction, and the details are included in the paper. In the accuracy comparison group, similarly, we can see the accuracy of the original biased classifier and of the classifier trained on the updated training data. Here below, we can see the overview of the updates of other values. And we only show the top 5 attributes that are mostly updated, because not only the attributes included in the patterns are updated, all the attributes of the data instances in the subsets are updated with the same direction. And by hovering the mouse on the bars, we can see the corresponding original meaning and the new meaning of the attributes, which can give us more insights about the updates. That's all for the demonstration. Thank you for watching.